Hello. Yes. Oh my god. Alright, holy crap. Um, well, I don't know how time flew by so quickly, but it's been, I think, like over a month since I've gotten live, or I guess 3 weeks exercise. But I have not been consistent. Yeah, basically almost over a month. Almost a month. And somehow I got like 100 subscribers now, which is like a lot. Like I don't want to feel like people are watching me. Like I still want to feel like I'm just like sharing for myself and documenting it. Um, but anyways, I was reflecting on, I guess, like the reason I stopped doing the readings was because of sort of this note I wrote around a week or two ago, which is like I felt like, you know, as I was reading these papers, like I don't know, I still think I need to spend time reading papers, but I really need to spend more time just like implementing, because at the end of the day, what do I say here? Uh, it can be a very big crutch because you don't understand what the model is doing. Code is truth, I still stand that, and code is still a lower level abstraction of what your ideas are. And if you want to be a 10x engineer or developer, right, it's being able to jump between these levels of abstractions. So not only being able to say at a high level what your architecture does, but seeing at a low level how it is actually implemented. Like let's say we say flow matching, and like you can just visualize in your head how the equation is implemented, right? The low level details. And so this is what I mean, is that I feel like I need to hone this skill way more right now, because if we lose the details, we lose it all. Um, and so in that sort of like pursuit, I think I really want to speed run sort of like these architectures, because a lot of these architectures, like we are familiar with, but I don't know, it's just like it's good to brush up on these. And I've implemented like neural networks like millions of times, for whether it's like through internships or like my own projects since high school. But it's always very easy to figure out the details. And so throughout this, I'm going to be battling with like what is the level of abstraction that I'm going to implement this at, right? Because like let's say you could just do it in purely NumPy, or in which case you don't get like the gradients, or you can just like try to like max out the level of abstraction you have, right? So I already kind of started this. These are the data sets, image data sets. We're mostly going to be working images. And my interests, to reiterate, are like robotics, right? And so a lot of these robotics, they use VLMs, they use diffusion. So I think it'd be good to just like be really, really, really familiar with how these things are implemented. And as I, do some exploration with world models, sorry. I just like need to implement this. So like JetBrains, I really want to use it. But I just want to be able to build a better intuition and a feeling of how these models work. And that just only comes with practice, right? So let's start with MNIST. And CFAR10. So I was like, as this is the motivation, and as I implement this, I don't want to use any AI or Copilot apart from at the very end of the process, right? Because like I think all of these Copilot can probably like zero shot. Right? It's like very, very simple. There's like tons of resources on this. So that defeats the purpose. The purpose is like get a very deep mastery in your own feeling of like what works and what doesn't work. So we're going to start with like a simple CNN and doing classification, and we're gonna use the CFAR10 dataset. And so I already started this. Like originally I was like gonna write my own data loader, which we could, but then it's just like, do I really want to do that? Like, I don't know. Maybe I'll just keep it here somewhere. Like I was writing this from scratch, but like this is just like purely syntax. But it makes you appreciate, I guess, the details, because you want to understand what goes on when you have a data set. Like this is sometimes too abstracted away from you, right? And you want to understand like, okay, what is this actually doing under the hood? But sometimes you also don't care, right? So I don't know, there's always this weird balance. Because if I do my own data set, then I just need to do my own class data set, and then you need to define three methods, which is get item. It's somewhere here. You need to define three methods, right? The index, when you call get item, how do you actually get the item? The length, which is the number of samples, and a function. You just need to define these three methods. Yeah. But yeah, so I was like starting on this, but then I was like, you know, I like there's CFAR here, and like if people use this code base, like they will probably. So I don't know. I'll just revisit this in a later period. For now, like I want to like focus on the modeling side, and also like if something doesn't go well, if something doesn't work, I guess like debugging it is a bit harder. Like I want to be able to compare my implementation against other people's implementations, I think. So for example, one detail you lose when you do these loaders is like, what is the representation like of the images? Like what are the channels? Like you sort of don't know that. If you implement here, maybe it's a bit easier to figure it out. Anyways, we're starting with the CNN. So the sort of like most basic architecture. So CNN, right, there's convolution layers, then some like pooling layers, then there's MLP, and then some smooth action head that's like the output. Now I have no idea, sort of like I haven't written a CNN forever, but we're probably gonna do something like nm.modular. And then yeah, I guess the goal is like, sure, like syntax is nice and everything, like, or like you don't really need syntax. And yeah, I'm going to try to do this without looking at a tutorial, because I guess there's tutorials for everything. I guess like once you get to the VAE sections, like more complex architectures, there's no tutorials. So I need to build it from scratch. But maybe for CNN, you know, like the data loaders, we need this. Okay. All right. So let's do a plan here. So what we need to do is, okay, for all of these, generally is like load data set plus data loader. We're gonna define architecture, and then define loss, train, and validate. I think like those are the general steps. So our data set for this one, our CNN, is going to be CFAR 10. There's like I think 10 different classes, and so what is the loss that you're going to use? You're going to use whatever the multi-class loss is. So see, like already, I'm not super sure, because usually the loss is like I use flow matching or like cross entropy for token prediction, but I'm not familiar with these other losses. Okay, well, we have a train data set. I wrote here to do, we need probably image augmentations, but these are just black and white, so like don't you even worry. So we need a data loader. How do you get a data loader? Data loader. Okay. We need a data loader, so we have a train data loader. We probably want to wrap this in like if name we're gonna do this later. So data loader. So our data loader takes in a data set, and what else does it need? And a batch size. Anyway, okay. Where we need later. An hour. Okay, we're gonna have a batch size, and shuffle is true, and then we're going to do the same for our test set. And really, you should have a validation So I don't know where to do this for lab validation, but okay. Also, I should probably make this bigger. Okay, like not brain dead big. And I'm gonna just do a fucking, sorry, why am I swearing? And if you shift enter, no, shift enter, we can, oh, okay, this one we're gonna do, oh my god, environments, deep learning from scratch. Shift enter, I think, okay. We can execute this code. Alright, so our train data loader, we have that. So what we can do is like, we can do next train data loader, and that, oh, we probably need next iter. No, how do we iterate again? Oh, yeah, okay. So here we actually need to apply transforms because it is not a tensor. So, yeah, I think you, yeah, I guess you do here, you have the tensor, so the tensor. Okay. If we run this, and okay, it's a list. What does this return? Here we probably want to like visualize this data set like they did. Here they use MNIST, but this label map, not sure where they got this label map. We can extract it's a tuple, so yeah, it's the image and the label. How do we get the label from the data set? Torch data set. Is there metadata on batches meta? Label names, I see. So we should probably, I guess that's probably why you want to here, I'm gonna ask chat. Really? That works? It is docs. I don't know. Hmm. See, like, it's not even. These classes. Yeah, I don't see it, man. See, like, how would I figure this out without chat? Like, you don't want to be crutching on chat. One sec, I need another drink. It's so hot. It doesn't say that, bro. Where's the soil? Steve R10. I don't want to log in, man. Class to index. Okay, let me do a search here. Yeah, it's okay. It's not built in. It's in data set. What? Yeah, this is here. Class to index. Okay. So we can visualize it by sampling a bunch of images, and we can visualize it. And let's do that. So visualize it. Okay, this one I'm not gonna. I don't want a label map. This should be like label map. Okay, so we have dataset dot class to index to class. Is there index? VK for KV and dataset dot items, right? I think that's like that. Okay. Let's try this. Can we visualize it? Oh, invalid shape. Data set. Yeah, we need to apply a transform as well in terms of the dimensions. So I think we need torch, and I guess like learn the basics. Put model, deep learning, PyTorch. Yeah, this is good one. C410 is so what we want is transform to compose, and they also have like torch transform v2. v2.compose. Yep. So why why didn't they put the transforms logic in the data loader as opposed to the data set? I guess because when you're loading it and the preprocessing, like, shouldn't it be in the data loader? Let's see, the data loader. Okay, fine. V2 dot. So we're gonna compose a series of transforms. I see. So you're just gonna do v2 dot to because yeah, at inference time for robotics, we need to worry about the same series of transformations that we applied on our input data, right? Like we should be able to see it very clearly. Okay, so I am also curious, like, how this works. V2 tilde tensor. If your input was, multimodal, right? It's not just a single image. Like, why is 2tensor deprecated? V2 and it normalizes it. Scale equals true. What about 2 images is tilde? Okay, but I guess what we want is v2 to image and scale it, and we also want to flip the channels which it's because the dimensions is. It removes the first dimension if it's. Okay, so all dimensions are single dimensional. Okay, I see. Did it? I thought they had an example here where. Basics. Did it not like? Oh, what's target? Wait. What the fuck is target choice? Okay. I guess it's generally like. Yeah. That's what makes it complicated. So, what do you do? I guess your keys are hard coded anyways. Okay. That makes sense. So we want to visualize it, and I can reshape it, but is that, did they show reshaping? Or was it, I think why the to I guess convolution because of the channels. I guess I'm familiar with black and white, but in 3-channel. Okay, it's multiplied by channel. So does the layout of whether it's CHW versus HWC matter? That's interesting. Oh, sorry, code. I don't know why. Use of how memory access works, but like your kernel is also two-dimensional. So like, I guess it's like how image is stored. So channels are contiguous. Okay. Spatial neighbors are contiguous. Yeah. Or you just and use this. Uh, still not quite following. But I want to just dot products and it all has to do with like the way it's optimized in terms of its memories, right? So if it expects the like, I guess the reason it's slower is because it expects the channel dimension to be the smallest. So it's gonna make the height and width multiplication much faster. But if then you use like HWC, right, it's gonna make W and C faster, but H is it's like much slower. And yet, if you do this layout, the H is like much bigger, so it's not as efficient. Is that sort of how it works? Okay, I think I get it. Huh? Oh my god, this is getting... It should work actually. Because the color map was gray. Look. That's not right. Yeah, I don't think torched up. Okay. Yeah, reshape is not it. 1, 2. Okay, that should be right. Okay, these are really not high pixelated. Okay. let's put this in like. We don't want this. We want. Okay. Alright. Alright, all this because we have data loader, we have batch size, 64. And now we're ready to, for data in data train data loader. Is that how we do it? Enumerate. Why is it, why is it comma 0? Yeah, it just adds a key. So y should pass 2 arguments. Oh, you still do cost entropy, or? Yeah, okay. Yeah, so this is what we need to do. We iterate over the data loader and we complete the prediction, and we have a loss function, and the loss function should be yeah, cross entropy loss, because we're predicting classes, and we know the ground truth y, and then do backprop instead, and then we print the loss, and we should have a validation loop. Yeah. Criterion? What do you call a criterion? Yeah, here's the validation set. really we should have three different splits. Torch utils data random split. Okay. Chain. So it's random split. Really, you should not. Torch dot utils dot data dot random split. If I make this smaller, just don't feel. Now everything's smaller. Can I make? Dot random split. I'm gonna do an 80-20 split. Shift enter. Can you do that? Okay. So this is how we're gonna know if we're overfitting. Yeah, I guess like we can even do like 0.9, 0.1. Because it's a lot of data. Optimization loop. I guess this is a generator, so if you do iter on a generator, it doesn't make sense, does it? Is this allowed? What's the point of iter then? Because they do iter. It's already an iterable, right? Just a generator. If you just did next data loader, it'd not work. So it's an iterable and not an iterator. Okay. But then I guess no, because it's iterable. Got it. Okay. So let's build our CNN. Okay. This is where I need to brush up. We have the forward function. We have an init function. I guess you always call it x. And then you return, and there's a differentiable. Import torch.nn, torch.modules.nn. I guess torch.nn. And we define Like, what does it provide? Alright, so we have torch. In channel kernel size. Mm. I'm not sure about this part, guys. I guess like if you do sequential, you don't need to. Push a sequential. Some really linear and ReLU, let's say, right? And sure, we can do like photo by 10, which is the number of classes. and there's no pooling. God. It's like calm to the. I'm not super sure like how it works. Yeah, it's been so long since I've worked with like convolutions. You can just use AlexNet. Like that's not fun. It's like number of channels. There's 3 channels and 3 channels out. Pooling just means like you take some of you take a patch of image and you can do like max pooling or min pooling, which is just like, oh, the value is just gonna be the max of those values. Padding mode zeros. flatten. Okay. All right, it's 9:40. All right, we're gonna finish the CNN tomorrow. Um, we're gonna get to CNN and finish CNN from scratch, and then we're gonna do Transformers. Uh, Vision Transformers. Do like implement connections, compare performance against reference. So we'll probably do AlexNet. BJJ. And then I really want to get to JEPA and the generative models. Okay, we need a unit. Yeah, I think it's not too complicated. I just need a bit more time, and I'm getting a bit tired. But yeah, 6:30 tomorrow morning. Let's do it.